Okay, now we're going to look at a specific exponential function that some of you guys might see in real life. Our specific exponential function that we're talking about is going to be interest that is compounded at certain intervals. So it can be compounded annually, meaning it's compounded once, compounded semi-annually, twice, biannually, twice, quarterly, 4 times, and so on. Right? So this is going to be talking about money. Now, when we do our general form for our equation that we went over on the last video, it's y equals a times b to the x power. And all of that is still the same. Y, which is your a, that's the amount of money after a certain time, which is our n value. Okay? Your p, well, that's in the same spot. That's your a. Your p is what they call principal payment, or your principal, and that is what you started with. That's how much money do you put in your savings account, is your principal. Okay? Then, this is where it gets a little bit different. So the b, our rate of change, your rate of change is this whole thing right up here. Okay? So it's that 1 plus r over n. So what is my r? Well, your r is going to be your interest rate. When you figure your interest rate, they're going to give it to you as a percentage, and you guys are going to have to turn that into a decimal. Okay? And then your x, which is this part at top, your x is going to be a combination of n and t. N is how many times it is compounded per year, and then your t is going to be your years and time. So those two together make up what your x value is. Okay, so it's still the same equation. It just gets a little bit more complicated on your b and your x. Okay, this is not something that you will have to have memorized. Not something that you have to have memorized, so don't worry about that. That will be given to you when you are working on these assignments. Now, the only other thing I want to cover is this n, as far as how many times, just some basic words that you guys can see. I already said annually. Annually would be 1, an n value of 1. Okay? Biannually. Okay, 2. Semi-annually. I think they usually use semi-annually, and that is 2 as well. Quarterly. Quarterly would be 4. They're going to do it 4 times a year. Tri-annually would be 3. Some other ones would be monthly. If they're doing it monthly, what would it be? Well, monthly would be 12. Okay, they could do weekly. There's 52 weeks in a year. They could do daily. I don't know if they do it daily, if they do 365, or if they do 365.25. Probably figure it out each year by year. So I'd say 365.25. But I don't know that much. I don't work at a bank. So anyway, but that is what all of your n values could be. So essentially what you're going to do on this one is they've already given you this equation, but what we're going to do is they're going to say, hey, what's the principal? Or sorry, they're going to say, what's the amount left after this certain amount of time? And you guys will plug in your principal, plug in your interest rate, plug in how many times, and plug in your years. And the reason that we're only going to work on simplifying this stuff is we need to have logarithms to be able to help us find some of that other pieces of information, which we will eventually do, but we've got to cover logarithms before we can do that. So, starting out, real life exponential function. Okay, suppose $4,000 is deposited in an account. How much money will be in the account after 7 years if the interest is compounded monthly at a rate of 2.75? So for this lesson, when you're doing this, you guys are going to be asked to find your P. You guys are going to be asked to find your R. You're going to be asked to find your N. And you're going to be asked to find your T. Okay, remember your P is just your start. Your R is your interest rate. And remember, when we do our interest rate, we're going to have to put that in the decimal. N is how many times is it compounded in a year. Number compounded in a year. And then T is going to be your actual years. Okay? So we need to look through this question up here, and we need to identify each of these pieces of information. And with that, once we find that, we will do our A figure out what our A is. So we're going to find those, and we're going to plug those into our formula here, like so. So, reading through, suppose $4,000 is deposited. That is going to be my p-value. Remember, that's where we start. So there's 4,000 in there to start. Got it? How much money will be in the account after 7 years? 7 years, that's our time. So we've got a 7 in our year spot. Right? If the interest is compounded monthly. So if we see monthly, how many times a year is that compounded? It would be 12. So we've got 12 times here. And then your R would be your interest rate. It is 2.75%. However, we're not going to be able to plug that in, so we need to call this 0.0275 would be what we have to use for that. Okay? So I'm going to go through my equation. I'm going to plug these values in. A equals P, which is 4,000. And then in parentheses, I've got 1 plus my R. Remember, that has to be a decimal, so 0.0275 over times its compounded per year, which is 12. Okay? And then in parentheses, I've got my N, which is 12, times my T, which is 7. Okay? Now, when you guys go through and do this, you can end up plugging in this all in your calculator. Sometimes that causes some issues. What I usually do to try to alleviate that is kind of similar to what we did with our quadratic formula. I simplify and figure out what this number is. And I also simplify and figure out what this number is. And then I plug that in my calculator. So when I do this, I'd write A equals 4,000. And then in parentheses, I would do what is 1 plus 0.0275 divided by 12. Okay, it just makes it so there's less spots for you to make mistakes on it. So when I do that, I get 0.0275 divided by 12 gives me 0.002291667. Okay, I do want this to be probably more accurate, so I'm going to leave a lot of decimals here. I'm also that way. I prefer to leave a lot of decimals rather than not leaving very many. Okay, so that's the number that I get on the inside, and then I've got to take 12 times 7, which I believe is 84. Okay, and now that gives me something that's a little bit easier to plug into my calculator. So 4,000 times 1.002291667 to the 84th power. And when I press enter, I get that there is going to be $4,848.04. And I am going to round that number because only 2 decimals when you're dealing with that. So that's how much would be in your account after 7 years. Okay? Next one down here. Got a savings account earns interest at an annual rate of 3.5%, compounded by monthly. If the account begins with a principal amount of $5,000, what is the value after 4 years? So wrote it differently, but still same rules. What does P equal? What does my N equal? What does my R equal? What does my T equal? Pause the video, see if you guys can figure out what those equal. Okay? Gives me an annual interest rate of 3.5%. I've got to turn that to a decimal, so it's 0.035. That I wrote that in the wrong spot. Daggone. 0.035. Okay? Next, it says that it is compounded bi-monthly. So that's a new one. Bi-monthly. Bi means 2. So twice a month it's compounded. That would mean 24 times because there's 12 months. Doing it twice a month, you get 24. So our N would be 24 on this. The account begins principal of 5,000. Okay? What is the value after 4 years? So we're going to plug that in. Again, you don't have to memorize this equation. It will be given to you. 5,000, 1 plus my interest rate over how many times it's compounded. And I've got that 24 times my years of 4. Okay, again, I would simplify it inside the parentheses and up top first. So when I do that, I've got 5 divided by 24, add 1 to it. I get my A equals 5,000. 1.0014583333, and then 24 times 4, I believe, gives me 96. Okay, something that's easier to plug into my calculator. So I get 5,000 times 1.0014583333, and I take that to the 96th power. Gives me $5,750.78. Okay. So for now, those are the only 2 forms of word problems we're going to do. As you guys work through, we will do more with these word problems as far as figuring out different pieces of information. But that's a good place for us to start out with those.